Good day, grade 8s, and the happiest of greetings to each and every one of you. Wishing you a warm welcome to the WorksheetCloud grade 8 Natural Sciences lesson. I'm delighted that you could join us today. If you have a question during the lesson, send an email with your question to grade8@worksheetcloud.com. I would like to share a quote with you at the start of today's lesson, and this quote is by Henry Ford, and it says, "Anyone who stops learning is old, whether at 20 or 80, and anyone who keeps learning stays young." And what I'm so proud of, grade 8s, is that you have taken control of your learning during this time, and you are learning what it means to be intrinsically motivated, and that learning is actually a lifelong process. And if something is really important to you, you will make absolutely every effort to get it done. So I congratulate you that you have chosen to take control of this learning, and that you definitely are going to keep yourselves young. So for those of you who've joined the lesson for the first time today, my name is Mrs. Ernston, and I'm the WorksheetCloud grade 8 Natural Sciences teacher. To those of you that have been watching all the lessons, well, you've remembered to have your books and notes and everything ready. So if you need to pause the video while you go and get all your things, please do. I'll wait for you. So the topic of today's lesson is density. And this is our third or fourth lesson in the series. So if this is all a bit new to you, please will you go back and review our previous lessons after you've watched today's lesson. Or if you feel that you are part of today's lesson and you don't quite understand it, please go and review the previous lessons and then come back to this one. Because today is a really fun lesson. We're looking at an online simulation. And in that process, we're going to explore the density of liquids and solids, which will hopefully help you to create a definition for density. We'll work with the mathematical relationships relating density to mass and volume. And you are going to see how to determine the density of unknown substances using mass and learning how to calculate volume. And then you will also need to make reference to density tables or density values. So to engage at the beginning of the lesson, here I've given you a couple of substances. I have given you gold, diamond, ice cubes, apple, and petrol. And I would like you to think about, if we had to add these to water, what would happen? Would it sink or would it float? So at the end of the lesson, you can go to this link that I've highlighted here at the top of the page. And if you just type it into your internet browser, you can go and explore all the different options and activities. And there's not only density, there are lots of other simulations there as well. But for the purpose of today's lesson, we're going to have a look at density. Don't worry, you don't need to go there now. I will take you through all the links in today's lesson. So pause the screen and copy this URL down, and at the end of the lesson, you can go and do some exploration around the site. So when you get to the Phet density simulation, I need you to select the mystery blocks, or for today's lesson, we're going to select the mystery blocks. So we have got blocks A to E to choose from. And what we are going to do is we are going to determine the mass, the volume, and density for each block. And then we are going to use a density table and try and determine the likely density. And then I want you to see if you can order the mystery blocks from least dense to most dense, and if you are able to provide me with an explanation as to why you put the blocks in this order. So if you type this website into your URL, it will take you to this type of page. So you might have to download it. and add it onto your computer. Some of you might have the Phet simulation already added on, at which point you will just click the play button. So let's go ahead and click the play button. So when that happens, it will bring you to a screen that looks like this. So here we have a container of water, and it is 100 liters of water. Here we have a scale that we can record the mass of the blocks on, and the units are in kilograms. And over here are the different types of simulations you can choose. And for today's lesson, I would like us to choose the mystery blocks. So we are going to calculate the density of 3 mystery substances. So a reminder that the equation to calculate density is mass divided by volume. And here is an information sheet if you do need it. So you are welcome to pause the screen and copy this information down. And just so that I go through it with you, density equals mass divided by volume. Mass equals density multiplied by volume. Volume equals mass divided by density. And there are various units that we can use for density. The standard ones are grams per centimeters cubed. We can also use kilograms per centimeter cubed or cubic meter. However, in today's simulation, because of the units the simulation has provided us with, we are going to be recording mass in kilograms and volume in liters. So you can pause the video now and copy this information down if you need. So just as a reminder, in today's lesson, we are going to determine the mass, volume, and density of blocks A to E. The other skill that I want to teach you this lesson, or that we are going to revise this lesson, are tabulating skills. When you do a table, you must always remember that your table needs a heading, and in that heading, you need to think about your independent and dependent variables. So let's go across here to the question and see what it's asking us to do. It's asking us to calculate mass, volume, and density. So your dependent variable is determined by what are you recording, what are you writing down, what are you calculating. So in this investigation, we are going to be recording mass, we're going to be recording volume, and we're going to be recording density. So those are going to be our dependent variables. And that is our output. What do we get out at the end of this experiment? So in order to get those values out, we need to have some input. And this is what do we have at the beginning of an experiment? And that is our independent variable. That is, what are we looking at? What is our input? So our input is 5 blocks, A, B, C, D, and E. The next thing your table needs to have is a heading, and it must be underlined. Then your table needs grid lines, and you must please do this with a ruler and a pencil, and the lines must be nice and straight both vertically and horizontally. Each column and row needs a heading, and then generally what we do is in our first column we put our independent variable, and in the columns thereafter we put our dependent variable, or in this case variables. Please be reminded that that we put the units in the column, row, and headings. There are no units in the main body of the table where you fill in your results. Ensure that you have completed every single block. Don't leave any blocks blank or open. And please remember to work nice and neatly. This is a very important skill to learn with respect to scientific process skills. So before we continue with this lesson, I would like you to draw up your table so that as we progress through the lesson, you are able to fill in the results as we go. So please pause your video now and draw the table that is needed for this investigation. Okay, well done. Now you have your table all nice and neatly drawn up. Let's go ahead and start collecting our results. What I have done here is I have added the density table, which has got the different materials and it's got the density value. And I got this density table by clicking on here, the density table, and it provided me with the table. Okay, so now we're going to start off with block A, the yellow block. So we take block A and we put it on the scale, and it tells us that the mass is 65,14 kilograms. Then I take the block and I put it into the container with liquid. Now this is going to help me calculate the volume. And the units for volume we are going to be learning about or using today are liters. So before the experiment, our container had 100 liters. And then we put block A into the liquid and it went up to 103.38 liters. So how do I go about determining the volume here? Well, what we do is it's 3,38. I take 103.38 liters, that is my volume at the end, and I minus my initial, so that's the volume, of my block and my water, and I minus the volume of the water only, which is 100 liters, and therefore I will be left with just the volume of the block. So the block is 3,38 liters. The mass I got from here, it's 65.14 kilograms. So if I use the equation, density equals mass divided by volume, I take the mass, I divide it by the volume, put it into my calculator or do it in my head, and there is my answer, 19.3 kilograms per liter. So how can I identify the likelihood of what substance it is? Well, we go through to our density table over here, and you can see that the density of gold is 19.3 kilograms per liter. So a possible identification for this substance would be gold. However, I would need some more information about observable features of the substance, because some substances can have the same or very similar densities. Okay, let's have a look at block B. So our mass for block B is 0.64 kilograms. Our volume for block B is going to be 101 liters minus 100 liters. So we write our equation, density equals mass divided by volume. Here our mass, 0.64 kilograms, and 101 minus 100 liters gives me 1 liter. So our answer is 0.64 kilograms per liter. And if we go across to our density table, that is the density of an apple. Let's have a look at the next block. So there is our mass, 4.08 kilograms, and here is the volume of the liquid and the block. So if I want the block only, I need to take the volume of the liquid plus the block minus the volume of the liquid only, and I will get 5.83 liters. So density equals mass divided by volume, 4.08 kilograms divided by 5.83 liters, and that gives me 0.7 grams per liter. And if I go up here, I find that my substance is gasoline or petrol. And our other block, D, our equation that we're going to use, density equals mass divided by volume. Our mass we get from our scale over here, 3,1 kilograms. How did we calculate the volume of liters here? See if you can explain it quickly to me. Okay, that's correct. So we've taken the block D. We have a tank of water. We put block D into the tank of water. The original recording of the tank of water is 100 liters. So this is the volume of water only. This volume here, 103,38 liters, is the volume of the water plus the block. So if I take the volume of the water plus the block, which is 103,38 liters, and I minus 100,00 liters, so I minus the water, I will be left of the volume of the block only, and that is 3.38 liters. If I use my calculator to calculate this, I get 0.92. And if we go here to the density table, we find out that our mystery substance for block D is ice. And now if we're going to have a look at our last block for you, I'll leave that up on the screen now, and I'll give you a few moments to do the calculations for yourself. So if you need to pause the video now, please do, and see if you can do block E by yourself. Okay, so welcome back, and let us see if you got it correct. So our equation, density equals mass divided by volume. We take our mass from the scale reading here, 3,53 kilograms. Here is our reading of our volume. So we start out calculating that here is our container that has got 100 liters of water. So we record that value. Then we take the purple block and we put it into the container of water, and it goes to 101,00 liters. So in order to find the volume of the block only, we're going to take the volume of the block plus the water, which is 101,00 liters. We minus the volume of the water, which is 100,00 liters, and therefore we'll be left with 1 liter. So we divide the mass by the volume and we get 3.53. We go across to our density table, and 3.53 is a diamond. So well done to those of you that were able to work out that calculation. So let us explain what we have just done. So firstly, we calculated the mass and density and volume of blocks A to E. Okay, then just double check your tabulating skills again. So you should have recorded this all in your table. So just check your table is all nice and neat. And let's now go and mark your table. So you go and you have a look at your heading. So can you see your independent variable? That is your input. What did we have at the beginning? Different blocks, A to E. So some of you might have said table showing the mass, volume, and density of different blocks. That's fine. That is your input. That's what you had at the beginning of the experiment. That's your independent variable. Some of you might have said specifically blocks A to E. That's fine. You might have said different blocks of different substances. That's fine. Then what is your dependent variable? What is your output? We were recording mass, volume, and density. And then remember to underline your heading, so you can give yourselves those marks. Then ensure that you have used grid lines, nice and neatly drawn with a ruler, so you can give yourself a tick for grid lines. Then your first column is your independent variable. So it's our mystery blocks, A through to E, and I've just added in the color so I didn't get confused during the experiment. Then remember, each column needs to have a heading. So this column heading is mass, this column heading is volume, and this column heading is density. Each row needs a heading. This row is block A, this row is block B, block C, block D, block E. So our rows have got headings. Then we need to remember that units are only in the headings. So our units here I've just put as color, It's not necessary. You don't have to do that. But these units are important. So mass we measured in kilograms, volume, liters, and density was kilograms per liter. So check that the units and the headings. Then check that every single block is complete. So check that you have these correct values recorded in. And then lastly, your table needs to be nice and neat before you hand it in for an assessment in a test or as part of a prac or in your exam. So well done. I hope you got full marks for your table and that you got full marks for all the correct calculations. All right, so the contents for this lesson. What I hope you've learned that each pure substance has its own density value. This value is constant. It doesn't change. And it is independent on the amount of substance there is. So it doesn't matter how big my apple is. It doesn't matter how big or small my ice cube is. It doesn't matter how much gasoline or petrol I have. It doesn't matter whether it's 1 ice cube or 10 ice cubes. It doesn't matter if it's 1 block of gold. It doesn't matter if it's a small gold ring or gold necklace. The value of the density value for that substance will always be the same, which means I can use the density value to identify a substance. And a reminder that the ratio of that mass to volume for a substance will always be the same. What we do just need to be careful of is some substances do have similar density values. So sometimes we can't always only go on this mathematical calculation. We do need some observable features as well. So preferably, what does it look like? What color is it? What does it feel like? Is it a solid? Is it a liquid? Is it a gas? That will just help us identify the substance further and create for a more accurate answer. So I'd like us to elaborate on this concept, and there is a really wonderful YouTube clip that you can go and watch. It's about density. It's what happens when we put ice and alcohol and water. So the clip is done by Bond with James, and I've put the URL at the bottom for you to go and have a look and visit. And I want to just have a look for us to discuss what is happening in this container. So in this container, we have pure alcohol. And in this container, we put in a block of ice. And what do you notice happened when we put the block of ice into the alcohol? So, which is more dense? Which has the greatest density? And which has the lowest density? In this container, here we have ice, and here we have water. So when we put the ice into the water, the ice floats. So between ice and water, which has the lowest density and which has the highest density? Okay, and then just to evaluate your knowledge for the end of the lesson, I would like you to have a look at this diagram, and I want you to see which of the substances floated and which of the substances sank. And have a look at blocks C, D, and B. They don't all float the same distance out the water. So how come D floats just on the surface? And how come just a fraction of C floats out the surface? And how come just a fraction of B floats out the surface? So those questions we'll answer in upcoming lessons. What I want you to do now is see if you can think about these substances and match them up with the blocks again. Are you able to remember looking at these blocks floating in the water? Where would you put gold? Where would you put the apple? Where would you put the petrol? Where would you put the ice? And where will you put the diamond, sorry. So to help you let's have a look at the densities. And are you able to put the blocks in increasing order of density? So what do we mean by increasing order of density? Well, we have a look here and we start with the one with the lowest density. And that would be 0.64, which is blue. Then the next highest number is 0.70, which is green. Then the next highest number is 0.92, which is red. Then we have 3.53, that is purple, and then we have 19.3, that is yellow. So now we have ordered our substances from in order of increasing density. So here we have our blocks of increasing density. So I want you to have a look at this, and I want you to see if you can match the substances with the blocks. So A would be your apple, C is your petrol, D is your ice cubes, E is your diamond, and A is your gold. So yes, gold and diamond will sink when we put it into water, and ice and an apple and a gasoline will float. So what have you learned today? So I would like you to draw this little sketch diagram into your notes, and I would like you to annotate as comprehensively as possible to this diagram everything you've learned and everything you can remember about today's lesson. So if I just help you with some suggestions, and then when I'm done, you can pause the video and do it on your own. So what is everything we've spoken about today? Well, those are not necessarily blocks of ice, they are just blocks. Okay, you can use blocks of ice if you want. So you can say that this is ice and that this is water, and you can say that this is ice and this is alcohol. So we've got solids and liquids. You can speak about floating and sinking. You can speak about the relationship with density equals mass over volume. You can speak about how do we calculate mass, how do we calculate volume, how do we calculate density. You can speak about putting things in order of increasing density or decreasing density, and you can try and explain why ice in certain substances will sink and why ice in certain substances will float. So you can make a really nice summary page on today's lesson. So you can pause the video now. If you have any questions through the course of today's lesson, please email your question to grade8@worksheetcloud.com. And this lesson was brought to you by Worksheet Cloud. Grade 8s, thank you so much for joining us. And please stay tuned. Every sort of alternate lesson, we will upload new lessons for you to watch during this time. And please feel free at any time to go back and watch previous lessons. And thank you so much for creating the time, making the effort, for being in charge of your learning, and for joining me today. Goodbye, grade 8s.